Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving the AISL paper 2, and this is of time zone 1 of November 2024 attempt. Let's start with the first question. So here is a grid which shows a restaurant's floor plan, and we have 4 food stations centered at P, Q, R and S. So I see P, R and S here, but Q is missing. So okay, Q point Q is not shown. 1 unit represents 1 meter. Alright, P is located at 2, 2. The equation of perpendicular bisector between Q and P and Q is y equals 4. This is the bisector between P and Q. So if this is P here, if you think it as a mirror, Q would be placed here. So this will be the position of Q. Fine, and the coordinates will be 2, 6. Fine, that's all over the first one. So we see point R and S. The coordinates of R and S are given. R is 11, 0. S is 12, 6. Find the coordinates of the midpoint of RS. So to find the midpoint, what we'll do is we'll just like you can use the midpoint formula, right? So midpoint M would be the sum of x coordinates divided by 2, sum of y coordinates divided by 2, which will be 23 over 2, which is 11.5, 3. That is the coordinate of the midpoint. Now we have to find the equation of perpendicular bisector. Alright, so what we can do is we can find the equation of the line passing through, or we can find the slope of the line passing through RS, right? And then we can just use the perpendicular formula, which is m1 m2 equals -1, to get the slope of the line perpendicular to it, and then we can make the line pass through this point. So in order to do that, first let's find the slope of the line passing through RS. So slope of line joining RS, this would be y2 minus y1 divided by x2 minus x1. This is the slope formula. So okay, we can take s as 2 and r as 1. So 6 minus 0 divided by 12 minus 11, which is 6. Okay, now let's say this is m1, and m2 is the slope of line, slope of the perpendicular bisector. So as they are perpendicular, m1 m2 will be equal to -1 and m2 equals -1. M2 equals -1 by 6. Fine, basically it's 6, m2 equals -1, m1 is 6. Yeah, fine. Now m2 is this, and I know that this line will pass through the point. This is for the perpendicular bisector. Slope is this, and it passes through the point 11.5, 3. So equation will be y minus y1 equals m x minus x1. So y equals minus x by 6 plus 11.5 by 6 plus 3. Okay, now if I plug everything in a calculator, I'm getting minus 0.17x plus 4.92. This is the equation of the perpendicular bisector, and this is the answer to B2. Fine, let's move on to the next part. Customers in the restaurant take their food from the nearest food stations. The following table shows the average waiting time in minutes for each food station, PQRS. Using nearest neighbor interpolation, find the average waiting time for a customer at point 6, 8. Okay, so first let's identify this point 6, 8. X is 6 and Y is 8. Okay, 6, 8 is in this. It's here, right? The closest food stall or food counter near 6, 8 would be Q, right? So we have to report the waiting time at Q. So yeah, waiting time at Q is 4, so answer would be 4 for this one, which is 4 minutes basically. Now the next part. The restaurant owner wishes to determine whether customers spend more money during the weekend. She decides to use a two-sample t-test at a 5% level of significance. Perfect. For this test, the null hypothesis is mu1 equals mu2. Mu1 is the mean amount of money spent by the customers on weekday, and mu2 is the mean amount of money spent by the customers on weekends. What is the alternative hypothesis? Alternative would be mu1 less than mu2. That is, the customers, the amount of money spent by customers on the weekend is greater than the amount of money spent by all the customers on weekdays. So this will be the alternative hypothesis. Now the next part, the owner considers collecting her sample data from 2 weekdays and 1 weekend by recording the amount spent on the first 12 orders on each of these days. State which of the following methods best describes the owner's planned sampling: convenience, system, or stratified. It will be convenience, of course. Now, why is it convenience? Because the owner only selects the first 12 orders on certain days, right? So it's not like she's picking up 12 orders from any specific days of the week, but it's 2 days and 1 weekend, completely upon her convenience, right? And and this method, actually, if I talk about the disadvantage, it does not represent the entire sample space. Okay, so yeah. The thing is, here we are just getting the data from the first 12 orders, right? Now it might happen that the first 12 customers in the morning, right, they might not have like that much time to spend on food, right? They might have to go to work and all. So, and the people who come late in the evening, they might spend more because they are spending more time, right? So yeah, so this method, I mean, this is the main problem with this sampling method. You cannot determine or make predictions of your entire data set using the first 12 orders. It will not represent the entire sample. Fine. Now p-value is 0.0897. What's the conclusion for the test? So p is bigger than 0.05. Okay. So there is insufficient evidence to reject H naught. That's about part F. Now moving on to the next question. So we have a Ferris wheel here whose lowest point is 8 meters above the sea level. So this distance is 8. And highest point is 45 meters from the sea level. This is 45 meters. So you have to show that radius of Ferris wheel is 18.5. So this distance is how much? This distance will be 45 minus 8, of course. So the diameter will be 45 minus 8, which is 37. And the radius will be 37 divided by 2, which is 18.5 meters. And that's it. That's all about part A1. Now we have to calculate the circumference. Circumference is 2 pi r. 2 pi times 18.5 gives us a value of 116.24 meters. Right. Now there are pods equally spaced around the wheel that carry passengers. So these are your pods here. Now, when the wheel rotates 10 degrees, find the distance the pod travels along the circumference. Let's say the pod moves here to here, and this is 10 degrees. We have to find this length, right? This one. Now, this is just your arc length. Arc length is r times theta. Okay. So, for the last part, d is equal to r theta. R is 18.5, the radius. Theta, they have to represent 10 degrees in radians. So, 10 divided by 180 times pi will give me the angle in radians, and if I put it in my calculator, I'm getting 3.23 meters. This is the distance moved by the pod along the circumference when the wheel rotates 10 degrees. Fine. Now let's try the next part. The height in meters above the sea level for this particular pod is modeled by this function ht equals a sine bt plus d. So we are looking at a particular pod right now. The wheel takes 15 minutes to complete one revolution. You have to find the value of b. So basically, time period is equal to 2 pi over b. Where this is your b exactly. So b would be 2 pi by t. Right. Now here, instead of 2 pi, we can also use angles. That is more, that is better for us, because in the previous problem too, we are using degrees instead of radians. Instead of 2 pi, I can use 360 divided by 15. So that will give me b equals 24. Right? So b is 24. Now you have to find d. D is basically the distance between the midpoint, okay, or distance between the mean line from the sea level, right? So here, this is the mean line, right? And this is the sea level. So I know this much is 18.5 and this much is 8. So, our small d will be the sum of these two, 18.5 plus 8. Should give us 26.5 meters. Now, what is the amplitude? For the sinusoidal model, amplitude would be equal to the radius, right, which is 18.5. The equation becomes ht equals 18.5 sine of b is 24t plus 26.5 meters. This is the equation of the sinusoidal model. Use the model to find the values of t when the height of the pod is 33 meters above the sea level. Now, so part D, you have to find, so ht is given as 33. 33 is 18.5 sine 24t plus 26.5. Okay. Now, if I simplify it a little bit, and write it like this. So 33 minus 26.5, it will give me 6.5. So sine 24t, 0.3513. Now we have to find the solutions of sine, between 0 to pi, because t equals 0 to 15. Right, 15 means a whole revolution, right? Whole revolution means you have to find two solutions between 0 and 360 degrees, so which occurs at the first and the second quadrant. So first solution will be 24t equals 20.57 degrees. Okay, and then the other one would be, it will be in the second quadrant. Second quadrant is 180 minus theta. So other solution is 180 minus 20.57. So first value of t would be 0.857 minutes. The second value of t would be 6.64 minutes. These are the two values of time when the height of the pod would be 33 meters above the sea level. Now the last part. So Ferris wheel has been operating for 3000 days. Each day is non-stop for 8 hours. Number of revolutions the Ferris wheel had made. Okay. Now, we have to find the number of revolutions in a day. Is working for 8 hours, right? So 8 times 60, right? This is the total time it's operating in minutes, and divided with 15, because for each revolution it takes 15 minutes. So this will give you 32. So it makes 32 revolutions in a day. Fine. And then number of revolutions in 3000 days, which is 3000 times 32. 96123. So I can do 9.6 times 10 to the power 4, and that will be the answer, because we have to give the answer in e times 10 to the power of k form. So here e is 9.6, k is 4. That's it. Now moving on to the next question. So a survey was answered by 2000 expatriates okay. So this was the result, like the country expatriate rank and the happiness score, right? For the happiness score, we have to find the upper quartile, interquartile range. Alright, so we can use our TI directly for this question. So let me show you how it's done. So first I'll click on stat, right? And then edit. And then enter everything, like enter the happiness scores in list 1, right? So it should look like this. Yeah. Fine. After we are done with this step, then we'll hit stat again, then go to calc and then hit 1, which is one variable stats. And then list will be L1, frequency list, you'll keep it as blank, and then move your cursor to calculate and hit enter. You'll get all the one variable statistics here. Now if you scroll down a little bit, you'll get the values of Q1, Q3 and everything required for this question. Let me show you how it looks like. So here's how your screen should look like. And yeah, from here, the upper quartile Q1, okay, upper quartile is Q3. Q3 is 7.2, right? So this one Q3 is equal to 7.2, and then IQR, interquartile variance, this is Q3 minus Q1. So with 7.2 minus 6.5, this is equal to 0.7. So we found the upper quartile and we found the IQR. Now we have to show that Switzerland happiness score is not an outlier for this data. Now Switzerland's happiness score, we have to first find that. So Switzerland, yeah, it's 7.5, correct? Now 7.5 is bigger than the upper quartile 7.2, right? So we have to check, which is Q3 plus 1.5 IQR, how much this value is, whether 7.5 is less than this value or not. Q3 is 7.2 plus 1.5 times 0.7. It should give you 8.25, right? Now as 7.5 is less than 8.25, Switzerland is not an outlier. For this data. Done. That's all about question 3. Now the next one. The next one is the happiness scores were ranked to calculate Spearman's rank coefficient R. These ranks are shown in the following table. So okay, so 7.1 is the highest rank. Its happiness rank is 1, and then we have to assign ranks according to the happiness scores. Fine. Now let's check the next one. Happiness 1 score is 1, 2. These are blocked. And after that, I see directly 5, 6, 7. So if you check here, New Zealand and Australia, they both have the same happiness score, right? And these two are basically blocking the 3rd and 4th ranks. But as they have the same score, right, 7.2 and 7.4, they will be assigned values as 3 plus 4 by 2, which is 3.5. Okay. So basically here, 1 is Switzerland, 2 is Netherlands, 3.5, 3.5, which are New Zealand and Australia. And then you'll move again from 5. 5 is Ireland, 6 is France, 7 is UAE, right, and so on. So A is 3.5, C is also 3.5. Now B is 6.5. 6.5 is basically smaller than 7. I mean this one, 6.6. Right, 6.5, 6.6, 7, 8, and 9 is 6.2. So B has to be 8, because B is within 7. I mean in between 7 and 9. So these are the ranks. So I'll just make a note here. This is 3.5, 8, and 3.5. That's it. Now we have to find the Spearman coefficient. Okay, so happiness scores were ranked to calculate Spearman coefficient R. So this happiness rank, we'll put it as our y-axis, right? And this expatriate country rank, we'll put it as x, right? Now how to get this done? So we'll put expatriate country rank as L1, right? And this happiness rank as L2. Let's quickly do that and let me show you how it should look like. Now this is how your calculator screen should look like after placing L1 as the country rank and L2 as the happiness rank. Okay. So L2 is this happiness rank and L1 is this happiness, the expatriate country rank. Alright, fine. After here, what you have to do is you have to click stat and then go on to tests, right? Test, you scroll down until you reach the LinReg TT test, this one. Let me show you. So this is the option you should be looking for. And when you choose LinReg TT, it should look like this. Now here, you will place X list as L1, Y list as L2. Sorry for that. Yeah. X list should be L1 and Y list should be L2. Then you will just scroll down and hit calculate. And if you scroll down, you'll get scroll down till the end, you'll get R squared and R value. The R value will be the answer to this question. And here is the R value. Let me paste it on another page. Yeah. So R value for this should be this last one, 0.16413. So RS is 0.16413. That's the answer to D1. Now for D2, if France's happiness score is upgraded to 6.9, explain why the value of RS does not change. If we change France's value from 6.7 to 6.9, so I have to check what's the, so for like Ireland has happiness score of 7, it has 5, and after Ireland we have 5 at 6.7, right, which has a rank of 6. So between 5 and 6, you see, like 5 has a score of 7 and rank 6 has a score of 6.7. So even if I make it 6.9, right, France, the rank, the happiness rank for France will not change, and that's why RS value will remain the same. So even when the score is upgraded, the happiness score or the happiness rank does not change. Doesn't change. So RS remains the same. That's it. That's all for D1 and D2. Now the next one. So Jose concludes from this data that countries with high happiness scores are likely to be favored expatriate countries. State was the reason why, whether Jose's conclusion is appropriate. Now Jose's conclusions is not appropriate because the Spearman's rank correlation coefficient RS is very small, right? So we cannot conclude that high happiness scores are likely to be favored like expatriate countries, right? Whether high happiness ranks or high happiness scores will give you like high expatriate country ranks. We cannot conclude that. So his conclusion is not appropriate, right? And just write it here. The Spearman rank correlation coefficient. Happiness scores likely to be favorite countries. Hence, Jose's conclusion is not appropriate. That's all about question 3. Now let's move on to question 4. Fine. So a type of dog food is sold in cylindrical containers. New label of the container is being considered. The label will be a rectangle that is 5 cm wide and 7 cm height. The design on the label is shown on the following axis, where 1 unit represents 1 cm. Okay, that's fine. The value in the table approximate points on the curve correct to 1 decimal place. So we have x and y values here. So we have to find the trapezoidal rule to estimate the shaded area in the curve. So we can directly use the trapezoidal rule formula as given in the data booklet, which is integral a to b y dx. This integral will be equal to half times h y0 plus yn plus 2 times y1 plus y2 plus up to yn minus 1, right? So h would be equal to the total, like the upper width minus lower width divided by total number of strips. Total number of intervals is 5, so h is equal to 1, right? So this will be equal to half times 1. The first value is 6 and the final value is 4.3. So 6 plus 4.3 plus 2 times the middle values, 1.7 plus 1.3 plus 3.0 plus 4.7. So if we put it in a calculator, we'll get this value as 15.85, and this is equal to the area. So 15.85 centimeters squared is the area of the shaded region found by trapezoidal rule. Okay, now The curve used to label this function can be modeled by this: y equals minus x cubed by 3 plus 3x squared minus 7x plus 6. We have to write the integral. Okay, let me do one thing. Let me put a page here and let me bring this text up to this page. Yeah. Now let's solve part B1. First, we have to write down the integral that represents the shaded area. The integral would be from 0 to 5, just the integral of y. So minus x cubed by 3 plus 3x squared minus 7x plus 6 dx. So I can directly take y because all of this function is above the x-axis, so that we don't have to worry about the negative signs and all. The second part is we have to find the area of the shaded region. We'll just have to finish this integral. So area would be, so integral of x to the power 3 would be it will be x to the power 4 over 4, and 4 times 3 is 12. This will be 3x, integral of x squared is x cubed, so 3x cubed by 3 minus 7x squared by 2 plus 6. We will put the limit 0 to 5 and 6x, sorry. If I put 0, everything becomes 0, so I have to put 5. So it's minus 5 to the power 4 by 12. 3 cancels out, so it's 5 cubed minus 7 over 2 times 5 squared plus 6 times 5. Now if I simplify everything, I'll get 15.41 centimeters squared. That will be the answer to B2. So B1 and B2 are done now. We'll move on to the next part. Okay, so this is a dog food is sold in closed cylindrical containers with radius r and height h. The whole container is made from one type of material and is assumed to that the thickness of the material is negligible. Alright, each container has a volume of 400 centimeter cube. So we have to write down an equation in r times h that shows this information, right? So volume of a cylinder is pi r squared h. So this it will look like pi r squared h equals 400. That's all about part C. Now, the amount of material can be modeled by external surface area. External surface area of the container can be expressed as 2 pi r squared plus k by r. So we are expressing the surface area of a cylinder using just the area instead of the height. So let's try this out. So for part D, we can just write height as 400 by pi r squared from the previous equation. And now we can say area is the top and the bottom surface is pi r squared because those are circles, and the curved surface area is 2 pi r h. This gives you 2 pi r squared plus 2 pi r. Instead of h, you can do 400 by pi r squared and add a page here. So it will give you 2 pi r squared plus this pi cancels out, r cancels out, so you have 800 in the numerator and r in the denominator. So this is the expression for area. So now what we have to do is we have to find the value of k. K is basically the numerator of this fraction, which is 800 if I directly compare it. So k is equal to 800. This is the answer to part D. Now part E, we have to find dA over dr. So if I just differentiate this expression here, ddr of 2 pi r squared plus 800 by r equal to 4 pi r minus 800 by r squared. This is dA over dr. Done. That's all about E1. Given A has a minimum value, find the value of R that will minimize the material used. So for maximum or minimum value, we have to equate, we have to find the critical points, which is dA over dr equals 0. So dA over dr equals 0 at minima. So 4 pi r minus 800 over r squared equal to 0. So if I multiply everything with r squared, so I'll get 4 pi r cubed minus 800 equals 0. Multiplied, in the previous one, I multiplied both sides with r squared. So r cubed would be 800 divided by 4 pi. And from here, if I find the value of r using the calculator, I'll get r as equal to 3.99 centimeters. This is the value of the radius where your surface area would be the minimum. This is the answer to E2. Now we'll move on to the last part, which is F. The containers are made so that the surface area is minimized. The 5 cm by 7 cm rectangular label is to be glued on the curved surface area to show that the label will fit on the container. Right? So for the label to fit the container, So we know r is 3.99. Let's find the height. Height is 400. We can use this equation, 400 by pi r squared by pi. R is 3.99 whole squared. So h is approximately equal to 8 centimeter. So r is 4 and 8. R is 4 centimeters. H is 8 centimeters. So yeah. Now the circumference, right, is 2 pi times 3.99, right, which gives you 25.07 centimeters. This is the circumference of the entire cylinder, right? Now if you look at it, the 5.7 5 cross 7 label will fit in any direction. Any direction. You see, first thing, right, the longest side 7 is less than 8, and the longest side is also smaller than the circumference. So you can put this label any way you want on this on this cylinder or on this can, right, and it will fit perfectly. And with that, we are done with question 4. Now moving on to question 5, which is probably the last question. Yeah, there's the last question. Fine. Jamali is designing a tent in the shape of a right pyramid with a regular hexagonal base, center O. Alright, so center O is somewhere here. It's that sloping edges. Length of each side of the base is 3 centimeters, or 3 meters, sorry. So this is also 3. This is 4.2, which is the sloping edge. Distance between each vertex and O is also 3. So basically, these distances are also 3 centimeters. Find the length of OT. Okay. Now we have to find this length OT, right? Now let's just connect them together. And connect these two. This is O. So OB is 3 centimeters from here. So this is 3. This is 90 degrees. Right? And then we have to find OT. For OT, we can just use the Pythagoras theorem because it's a right angle triangle. So, yeah. So basically OT squared plus 3 squared will be equal to 4.2 squared. Fine. So from here, OT will be equal to 2.94 meters. That's the answer to part A. Now part B. Hexagonal base can be divided into 6 equilateral triangles. Find the area of the base. So what we can do is we can find the area of one equilateral triangle and then multiply it with 6 because we have 6 triangles. So how to find this area? So this is all of the sides will be 3, and in an equilateral triangle all the angles are 60 degrees, right? So area would be 6 times the area of one of the triangles. So we can use the sine formula, half AB sine C. So half times 3 times 3 times sine 60 degrees. Okay. So if I simplify this, I'll get to 23.38 meters squared. This is the area of the base. Now the volume of tent. Now if you look at it, this tent kind of looks like a cone, right? So we can manipulate the volume of the cone equation to find the area. Find the volume of this tent. So volume of cone. This is 1/3 pi r squared h. Yeah. Now if you remember, pi r squared is basically the area of the base of the cone, right? So we can write it as 1/3 times area of base times height. So this becomes 1/3 area of base is 23.38, and the height of this cone is height of the tent is OT, which is 2.94, which we found in the last part. And if I simplify this, the volume of the cone comes out as 22.91 meter cube. That's all about part B. Now moving on to part C, we have to find the angle OAT. So OAT, we have to find this angle. So we can actually find this angle using trigonometry. This is 3. This will be 2.94. Right. So here, if you look at it, we can just use any formula you want. We can use cos theta. Cos theta would be 3 over 4.2. Yeah. So theta would be cos inverse 3 by 4.2. Let me put it in a calculator. Giving me theta as 44.42 degrees approximately. Right. So angle OAB, OAT, This is 44.42 degrees by trigonometry. So our part C, OAT is equal to 44.41 degrees. That's it. So we are done with the first three parts. Now moving on to the next part, we have like two of them left. For extra support, Jamali decides to attach a rope with length 3.5 meters to the tent at a point P on the edge 80. So at 80, there is a point P where another rope is attached for the stability or extra support, right? So we know that PQ is a straight line. Okay, the length of the rope is 3.5. This angle is 30 degrees, right? So to first find AQ, the length AQ of this, for EQ, okay. Alright, fine. Now what would be this angle? This angle is basically same as like we just found it here. It's 44.41 degrees. It's basically OAT. Or just let's take 44.4 degrees. Fine. So this angle QAP. So angle QAP, this will be 180 degrees minus 44.4 degrees. Fine. Which is or maybe let's write it down here. This will be equal to 135.6 degrees. This is basically this angle QAP. Now we can use sine formula, okay, then we can find this angle, right, as we need AQ, and then we can apply sine formula. So angle APQ is equal to 180 minus 30 minus 135.6, which gives you 14.4 degrees. Now applying sine rule, this will be AQ divided by sine APQ equals PQ divided by sine QAP. Fine. So from here, AQ divided by sine 14.4 is equal to 3.5 divided by sine 135.6. So from here, AQ becomes equal to 1.244 meters. This is AQ. And that's the answer to part D. Now the last part, for decoration at right, Jamali wants to fix a strip of lights from point A to point R, which is a long rope PQ. So there is a point R somewhere in PQ. Right? So maybe R is here. And this is the rope of lights. Yeah. The strip of lights is strained and the value is 0.8. So AR has a length of 0.8. Now you have to find the possible values of QR. Now if I just draw this triangle QAR, it should look like this. Or maybe if R is here somewhere, let's try to draw a regular triangle. This is Q, this is A, this is R. I know this angle is 30 degrees. I know AR is 0.8. Right? And I know QAQ is also 1.244. I have to find QR. So easily I can find QR using the cosine formula because I know one angle and I'm just missing one side, right? So cos 30 degrees would be equal to x squared plus 1.244 squared minus 0.8 squared divided by 2 times x times 1.244. So 2.154x equals x squared plus 0.908. If we just simplify a little bit, we'll get this expression. And then x squared minus 2.154x plus 0.908 should give you 0. So we will have the x values from here would be 0.575 meters and and x will be equal to 1.579 meters. Therefore, QR will be equal to either 0.575 meters or QR would be 1.579 meters. These two would be the answers to part E. And with this, we are done with the paper 2 of AISL of November 2024. And thank you so much for watching till the end of this video, and I'll see you again in the next video. Thank you.